Hello, everybody. Hang on, let me get my camera going. Hi. Hi, everyone. How are we all going today? I hope everybody is doing well. I am seeing myself in stereo. I have two things here. I've got lots going on. It's going to be an exciting night. We are coming to you guys live from Science Space in Wollongong on Dharawal land. And we're coming to you from our planetarium because we are going to go on a bit of a tour of the solar system with a very special guest. Hi, everyone. I'm just seeing you all say hello in the chat. That's exciting. Hello. Got so many things to click. Okay. I reckon we need to get our very special guest in. What do you reckon? We have a very special guest all the way from Sydney. Please welcome the wonderful Dr. Helen Maynard. Hello. Helen is a planetary scientist all the way from ANSTO, and you're a space ice expert. That's correct.
At least I try to be.
So Helen, where is it that you are kind of coming to us from today? Are you stuck in lockdown like all of us as well?
I am indeed. So I'm coming to you from Dharawal country. I actually live up in the Blue Mountains.
Hey, nice.
And and so I've been here, and it's not a bad place to be locked down in, really. But normally I get to go very often down to ANSTO, which is at Lucas Heights, which is in the wonderful place of the Shire in south of Sydney.
Amazing. What sort of things? Okay, so I just introduced you as a planetary scientist, right? And you tell me that you work right here in Sydney.
I do.
How does that work? What do you use all of the wonderful equipment at ANSTO for? What does ANSTO stand for as well, for those of you who don't know?
Oh yes. So yes, should have said that before. So ANSTO is the Australian Nuclear Science and Technology Organisation, and it's one of the number of government science research organisations that we have in Australia. So probably a lot of people might have heard of CSIRO. And then Geosciences Australia, who have been very busy today.
Very busy, right?
Earthquake down in Victoria. I hope anyone calling in from there didn't get too shook up. So ANSTO are in cover a lot of things. One big thing we do is we run the Opal research reactor, which is in Sydney at Lucas Heights.
That's cool.
Yeah, it's really amazing place that so we use the research reactor, we sort of squeeze everything we can out of it. It's mainly there to make medical isotopes. 1 in 3 of us in Australia are going to probably need those medical isotopes throughout our lives.
So kind of a medication, right?
Absolutely. It's used for tracing for all sorts of things, from cancer all the way through to sort of seeing brittle bones. Myself, I've actually had nuclear medicine a couple of times.
Cool.
I don't have a thyroid anymore, so I had to get that taken out. But so it was really funny when I went for it, and they were like, "Oh, this nuclear medicine came from ANSTO. Have you heard of it?" I'm like, "Well, actually, I have." So that was quite good. But the other great thing that ANSTO does is it runs some really big science machines for the benefit of not just for Australian researchers, but for people all over the world. And so these are things like the Australian synchrotron, which is down in Melbourne, which is a footy field sized particle accelerator, which accelerates electrons up to close to
super
the speed
fast.
of light. And then you get little high energy X-rays coming off, and they use them for lots of things. I work for the Australian Centre for Neutron Scattering. And so what we actually do is we're sort of attached, sort of suckered onto the reactor. And we use the sort of spare neutrons. They have quite a few spare neutrons. And we put like little beams in the way, and we pull out the neutrons. Well, they don't pull out, they just sort of bounce out themselves. And we put them at the end of all these neutron beam lines, as we call them. We have a number of instruments. And these instruments usually have a detector, and it will be determining, it will sit in lots of different ways. But then what we can do is put samples in the way of the neutron beams. And based on the pattern or the image we get on the detector, we can tell an awful lot about the material that we've put in the way of the beam. So yeah,
Okay.
so there's lots of things going on there, and you can imagine that I'm one of very few planetary scientists working there. We have engineers, we have lots of technical experts, we have chemists, we have biologists, so all sorts of people use this equipment. But I'm interested in using it for planetary science, and
Cool.
yeah,
Yeah,
and then
yeah.
that's basically what I do.
Kay Kim here says, this seems like a lot.
It does seem like a lot. I'm sorry, Kim. It's a lot for
Anyway.
6 o'clock, yeah.
Oh, that's fine. How about I flip our planetarium around so we can have a look at where we're coming from and where we are. And maybe you can point out where we are.
Ooh,
so here we go. Oh, there we go. All right.
Zoom, zoom. Oh yeah, we can see the national park. We're going down to Wollongong now. Excellent.
Yes. So I've kind of got us like half between Wollongong, half with Sydney. So Lucas Heights and Anstow is kind of at the south there of Sydney, that big blob up in the top there, right?
No, we're further up actually.
Oh yeah.
Yeah, so if you follow along the coast, you can sort of see. Hang on, I don't know if I can point or if it's going to work, but you can actually just see there's sort of like a white blob, which I think it's up towards the top of the screen, which I think that's roughly where Anstow is, around there.
Oh, that's cool.
Yeah, so that's roughly us, and you can see that we're sort of very much near the Royal National Park and
yeah,
near
nice.
lots of the bushland that's around Sydney and things like that. So yeah, and because you can see Sydney's further up, and you can just about see like places like Botany Bay and stuff from there. So yeah.
How about we go and zoom out a little bit? What do you reckon?
Ooh, yeah.
Okay. Yeah.
Let's go to the
so here
space.
We go. Yes. So you said that you study space ice. So what sort of objects in space have ice apart from Earth?
Apart from Earth. So as Joe was saying, one of the good things that we can do on our neutron instruments at Anstow is we can sort of use them to study planetary materials, and that's kind of one of the things I'm doing. I should say that planetary scientists are, as a group of people, are usually sort of a big group of jack of all trades, and they apply it, and we're all interested in understanding the planets a bit more. So they're not one type of scientist. We have some planetary scientists will be chemists, and they're interested in what sort of chemistry. Some planetary scientists are astronomers, and they're interested in seeing what's out there. Some planetary scientists are physicists, and they want to know sort of like how things are moving about and they interact. But I'm, as a planetary scientist, I'm very much interested in what the materials actually are. So what I do is I take the chemical information that we get from the NASA spacecrafts, and then I recreate the conditions of all these interesting icy bodies at the lab, and then I can try and find out what those materials are. Cool. So one big icy place. So for us, obviously, actually our Earth is quite an icy world. Like, you know, if you go to the North and the South poles, but of course there are lots of worlds where it's cold enough to be icy all over the place. So a good one might be if we go out to Jupiter. So Jupiter has 4 big moons, and let's try going to Europa. Let's try Europa. Yeah.
All right, let's get to Jupiter first. But
yeah. Oh, I realised maybe we should have stopped by the asteroid belt on the way.
That's all right. We can go back.
Can we go backwards and forwards?
Yeah, totally.
All right. I wasn't sure how long it took to get to Europa.
Yeah. Hang on a second. Just quickly, Tatenda has written in the chat here. And if you guys have any questions at all as we go through, just type them in the chat and we can answer them as best we can. I have a question about Jupiter. I read that something crashed into Jupiter last week and was visible. Did you hear about that?
It did indeed. And it's it's quite funny because I have my other half actually spends a lot of his time looking at Jupiter, and he was a little bit grumpy because he missed it.
Oh no!
I know, and that all his astronomy friends around the world had actually caught it. So yes, so Jupiter, because it is the biggest moon, biggest planet in our solar system, it's got quite a big gravity field, and it often gets hit by, well, would you call them meteorites? Because it's Jupiter. It often gets hit by other objects, small asteroids and things. A really famous example of that was the Shoemaker-Levy 9, which was a comet, which
interesting.
yeah, quite a long time before it was predicted, they charted its path, and they predicted that it was going to hit into Jupiter. And so loads of people were ready to look at it, and we got some really great pictures of it. It actually broke up a little bit before it got in. So if you're interested in things hitting Jupiter, it's worth mentioning about that. And actually that also reminds me, because it's Shoemaker-Levy 9, they're named after the people who discovered them, and one of the people was a woman called Carolyn Shoemaker.
Yeah,
and she was a very well-known comet hunter. She actually quite sadly passed away last week. So yeah, but it's really interesting. She had an amazing life through science, and is one of those very interesting people to read up into. So there you go. It's just I did a bit of extra work.
That's all right. Okay, how about we go have a look at Europa?
Yeah, let's go to Europa.
This is one of the 4 moons you were talking about, right?
Yeah, so
awesome.
yeah, so Jupiter has 4 really quite large moons. When I say they're large, I think Europa's actually a bit bigger than the planet Mercury. So although we don't think of them as planets, because they're actually moons, because they're going around Jupiter, they're sort of at the point where we need to start apply what we understand for planetary science to them. Europa is and these are called the Galilean moons because they were discovered by Galileo Galilei, who was the first person. Yeah, I know, isn't it? Like, yeah, everybody now has the Queen song in their head, Bohemian Rhapsody, right? And he was the very first person to take a telescope. Actually, he made a telescope and he pointed it at Jupiter, and he was slightly surprised to see 4 little stars going round Jupiter. And yeah, so that's why they were called the Galilean moons. So Europa is covered in water ice. So I think, as Joe said, I'm interested in icy moons, and I should say that for me, ice isn't always the same stuff you see in your freezer. It's not always water ice. What I mean by icy materials are things that we think of as that are gases and liquids, but where we go out into the solar system, go really far out from the sun, it's so cold that these things start to freeze. So a good example, and we'll probably get that far later, is like methane. So it's probably quite a famous gas. Comes out of cows. Cow farts. It's the main source of methane in our atmosphere, sadly, but it's a natural process to some extent. But it's a gas in Earth conditions. But when you get all the way out to some of the other icy moons, it's cold enough that it becomes a very wobbly solid. So these are the materials that I'm interested in. So Europa, as you can see, as it spins around, is actually, a lot of it is covered in water ice. And that's really cool. And actually, as we come around, I can't remember if this has it or not. Oh yeah, it's got some of the stripes and things on it.
Hang on. Let me see if I can stop it. 1 second.
Yeah, if we can pause it here, that's pretty cool. Yeah, that's awesome. Because you can see that there's sort of stripes and smudgy bits and things like that.
Yeah, there we go.
There we go, perfect. And those stripes, the smudgy bits, actually, so when Europa goes round Jupiter, it's actually sort of locked, tidally locked, so that only one face of it actually faces Jupiter. And
is that kind of like the moon?
Yes,
our moon?
Yes, very much like our moon. Yep, the same idea.
Yeah, right.
And the smudgy bits are actually, they're in the path of as it moves around. So what they think those smudgy bits are chemicals that are around Jupiter that are sort of hitting onto the surface. But what are those chemicals? Well, the clue there has been, Io has a messy little sister, a really messy little sister called Io. And Io actually orbits a little bit closer to Jupiter. And actually, it's so close. I don't know if we can go see Io, but its core rubs together. And because of that, it gets really hot. And it starts spewing out volcanoes and spews out things into the space. Right. And one of the things it spews out is sulfur, which is a very sort of yellow, smelly chemical in various guises.
It's kind of like rotten eggs, right?
It is, yeah. Hydrogen sulfide is rotten eggs. Yep, exactly. Yep. So, oh, there we go. And actually, that's the lovely thing about Io. You can see the volcanoes. You can see all this. It looks really pimply. It looks like it's a teenage.
It comes around to the light side. Why is it so dark? I
don't know. But that's yeah, weird. So Io puts a lot of sulfur out into the area. And so they think what's happening is that Europa's moving through the sulfur and it's splodging on the surface, and poor Europa wants to be all pristine and pretty, but is getting all the messiness from Io. So one of the things I got interested in is what happens when that sulfur smacks into the surface, into the ice, and it forms these various materials, and actually it starts grabbing oxygen and it starts grabbing all sorts of things, but it can form slightly different structures, slightly different materials to the water ice. And so that was one of the things that I spent a bit of time doing when I was at the Australian synchrotron. So that's kind of fun. Yeah. And the thing that I should say, the really exciting thing about Europa, well, there's lots of exciting things, but the thing that gets most scientists out of bed is that we think that there is an ocean underneath Europa.
This is actually related to Sam's question.
Ooh, okay.
He's got a question. He says, do you think Europa may contain life beneath the surface?
It is definitely one of our best targets, our best possibilities for life. What it is, we don't know. And the reason is that you've got this sort of thin, we think, and we don't know for sure, but we think a thin ice shell over an ocean. We know the ocean's there, we just don't know how thick it is.
Yeah, right.
And we think that ocean is probably quite a warm environment, probably not that different in temperature. It probably wouldn't be too bad to swim in, no worse than swimming off of Wollongong.
Really?
Yep.
And it's so far away from the sun.
Because it's protected by the ice over the top, and also it goes all the way down to the rocks below. And they think that it gets heated by the rocks below. So there's and we think at the bottom there could be things like the hydrothermal vents that we get at the bottom of the ocean and things like this. So not only do we have heat there, but the cool thing is there's minerals and there's chemicals coming, and so as soon as you have heat, that's an energy source, and as soon as you've got minerals, that's something to eat. So it's actually a potentially nice environment to live in, actually. I mean, not sure I would survive there for long. I'm not sure what the Netflix is down there, but you know, it at least and we have environments like that on Earth. So there's a lake called Lake Vostok in Antarctica. And that has been sort of covered away and locked off from the rest of the Earth for around 10,000 years, until I think it was about 8 years ago, when the Russians drilled into it and they managed to slurp a bit out, and they then looked and saw that there was some bacteria living in there. So if bacteria can live down there, maybe they can live on Europa. So it's pretty exciting place to be. I'm sorry, I stop talking and let people ask questions.
No, it's fine. We're getting some really good questions coming in as you're talking. So we actually had one about Jupiter. Cool. Nicholas wanted to know why Jupiter has those little spots. Let's go back and have a look.
It's got lots of both little and big spots. And so they're all storms. And so Jupiter is a gas planet. It's not, unfortunately, if you were to try and land on it, you'd just keep falling and 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 falling until eventually you'd get squished. So
the gravity is pretty hectic.
The gravity is hectic, is a good way to describe it. So it has lots of, even those little white dots down the bottom there, they're all
let's see if we can go back.
little storms, because because of the gravity, because of the sort of energy coming up. Oh, and of course there is the big spot, the great red spot, which is about the size of a couple of Earths, so they're not that small. One of the interesting things is we're actually seeing the red spot change, and scientists are not sure how long it's going to last, because it's a storm, so it makes sense that it will change and eventually maybe clear up. We're not entirely sure at the moment, but
it's
I
lasted
should say
for centuries so far, right?
Yeah, it has. Yeah, it was first observed at least 200 years ago. I think we've known it's been there because, obviously we wouldn't have known about it before Galileo first looked at his telescope, and his telescope wasn't good enough to see, but about 100 or so years later, telescopes got good enough that they could see. And there's lots of really brilliant historical sketches because they couldn't take photos, so they would do little sketches and things like this, which is kind of fun, actually. There's a lot about there's a lot of we don't know about Jupiter and the way its atmosphere moves around and things like this. But I should say, if everybody wants to lose a whole afternoon, go and look at the Juno Juno Cam images. So it's Juno. Juno's a NASA spacecraft that is actually investigating Jupiter right now. Well, it goes on a close bypass every, I think it's 79 days or so. It can't go closer because otherwise the radiation from Jupiter would actually fry its instruments. So the pictures from that are absolutely stunning.
Actually, all the images that you're seeing right now on the planetarium are from missions like that. So we get all of our images, the very clever people from Evans and Sutherland who make Digistar, which is the thing that we're using now. They use all of those images to make these pictures and things. There's a couple more Jupiter questions that have come through. Are we seeing rings on Jupiter?
Yes, Jupiter. Jupiter does have rings. In fact, all our gas giants have rings. They're not as famous as Saturn's rings, but they do all have them. So, and that's sort of all about the sort of leftover bits of rubble and things around, and because they've got these really big gravity fields. So it's not unusual. Although I think the thought now is that the rings are sort of a fleeting thing, that they sort of happen and then they go away. I know that some astronomers are showing that like Saturn's rings are not going to last very long, maybe another 10,000 years, which in a solar system context is like nothing, but for us is a long time. So it just sort of shows that I think that's an interesting point to make, is that we all think of the planets as very static things, as this is how it looks and this is how it is. And the reason I like planetary science is that no, things are changing all the time. Our understanding is changing. They are more dynamic. They are more some of them are like geologically active, like Io is geologically active, so they do change. And we can see those changes, which is really cool.
Awesome. So there's another icy moon that you study as well, right?
There is indeed. I like them all. I mean, I do love them all. Ganymede, which is also one of Europa and Io's, is Europa and Io's big sister, is there, and I should say that both Europa and Ganymede, hopefully in the next few years, we'll know a lot more about, because so NASA are sending a mission to Europa. It's called Europa Clipper. Should be going in 2 years' time.
That's cool.
Yep. And the European Space Agency are sending a mission called I think it's called JUICE, which I think stands for Jupiter Icy Moon Explorer or something. Yep. But they are going to actually concentrate on Ganymede. And
which is one of the reasons right here.
Yeah, it is. Yeah. And one of the reasons. Oh yeah, it's not as it's got ice all over the surface and things, and some people have been less interested in it because it's much bigger. It's they think there's an ocean underneath, but they worry that the ocean actually gets so high pressure that actually the ice solidifies because of the pressure, not the cold. And then people were like, well, that's not a nice place to live in, because, you know, you can't get your nutrients, you're not getting your heat coming through and things like this. So some people,
it's not as nice as Europa.
Yeah, some people have written off Europa, but it has another big thing going for it. So Earth, one of the things that's really important to us is our magnetic field. And one of the reasons that Earth is really different from Mars is that we have a very active magnetic field. Mars is not really there anymore. Ganymede actually has a magnetic field. And I think that's another, and so we think, we're not sure where that magnetic field is coming from. So I think that's one of the reasons why the ESA, the European Space Agency mission, wants to go there. And so we've not totally written it off as a potential place for life. So, but yes.
But this is the biggest moon in the solar system currently, right?
It is. So it stole the glory from the moon that you, the other moon that we should talk about, which is Titan.
Yes.
So Titan, which is the largest moon of Saturn, got called Titan because everybody thought it was the largest moon. But when they looked a bit closer, they realized it was sort of inflated itself a little bit. Oh, let's go.
We just went straight through
it. But yeah, Titan had inflated itself a little bit because it's got a really thick atmosphere.
Yeah, right.
And so when we actually got there to study, we realized that Ganymede is actually 50 kilometers bigger. It's not much.
Really?
Yeah. So yeah, that's kind of a funny fact story.
So
here we are at Saturn.
Just quickly, Subiana, you had a question. What's that cloudy thing in the background? That is the Milky Way. I've got the Milky Way turned on. We can turn it off, but it looks really cool.
It does look really cool. I like the Milky Way. I mean, I don't know much about it because my knowledge sort of ends at the end of the solar system. So that's where I figure that's enough.
Right? Just the solar system.
That'll do. But yes, so we have Titan here, and Titan sort of looks a bit big and fuzzy, and one of the reasons is because it's actually it's a little bit Earth-like. It has a really thick atmosphere. It's actually a nitrogen atmosphere. There's not much oxygen there, but it has an atmosphere, and if we could deal with the cold and we had an oxygen supply, we could actually walk along the surface. It's actually a little bit thicker.
Really?
So it's a little bit like, it would be like walking, like when you dive in a swimming pool and you dive that little bit lower and then try and wander about. It will feel like that. It will feel a bit soupy, like, you know, things are moving across you.
That's so weird.
And
I love that.
The really cool thing about it is that actually, because it's got that thick atmosphere, we could fly. I could flap my arms and fly on Titan. Totally
Seriously?
True. Yeah. Because of the thicker atmosphere, it's actually quite easy to fly. And actually,
I want to go.
And that's why the next big mission to Titan, which is the NASA Dragonfly mission, is that actually, and it sounds really audacious, but they're actually going to send a drone, a quadcopter, to the surface, and they're going to have it, so like, you know how Mars has its rovers and they fool around and do the stuff, and then the Titan scientists were like, I don't want a rover, I want a drone. He got one. So
absolutely,
it won't arrive for a long time, but when it does, and hopefully when it does, I will know a bit more about what materials it's going to expect, because that's where a lot of my research is at the moment.
Really? Oh, that's cool.
Yeah. So because this thick atmosphere has things like, has methane and nitrogen in it, they actually sort of combine in the atmosphere to be small organics and small molecules, and then they all rain down. And we know, as I say, we know a lot about the chemistry, but we don't really know what materials they are. So basically, so I take the chemistry and then I put it in my cryo furnace at the neutron source, and then I can make the temperatures of the surface of Titan, which is around minus 180 degrees C. So it's a bit chilly. And I can see what solidifies, what crystallizes, and study those materials. That's
cool.
Big thing.
So you're basically kind of like putting all of the ingredients into that environment, and then like seeing what you get from that sort of weird cold oven almost.
And
That's
yeah,
so
no, it's
cool.
kind of a cold oven. That's a good way of describing it. I'm going to call it the cold oven
It's
from now on.
baking, essentially, right?
Yeah, it is, because it can go hot as well as very cold. So that's why we call it cryo oven. And it's orange, so it's the orange cryo oven. I'm going to call it that. But I don't know, could we get a layer where you can see? So if there's the radar layer, so we can see in between the clouds. It's just
Maybe.
because
See what I can do for you.
yeah, because so when NASA did sort of want to send and Titan was interesting for lots of reasons, and people got really excited about it. So then NASA sent a spacecraft called Cassini, or it's actually Cassini-Huygens, and it went there with a radar because they were like, well, we could take pictures from space, but it's just going to take pictures of clouds, and that's not going to tell us anything. So what they did instead,
there we go.
This is brilliant, is they took some radar. And so the radar is like radio waves, and it bounces off the surface, and it tells you a bit about how rough, this is perfect, the surface is, and things like this. But one of the big discoveries, and you can see where everything is black there, it means it's smooth. And if it's white, it means it's rough. And you can see there's a lot of very, very smooth patches. And those smooth patches.
Let me bring up the coloured one again.
Yeah, because then we've gone through and mapped it now. Those smooth patches are seas and lakes that we know are there. And so, like Io was the first other body we knew to be volcanically active, Titan became the first body that we know, other than Earth, to have liquid on the surface. But it's minus 180 degrees C. So it's not liquid water. It's liquid methane and ethane. So it's liquid cow farts.
So if we went to Titan and went flying, we'd be flying through liquid cow farts.
Oh no, that's only if you went swimming.
Oh, okay.
Yeah.
Great.
If you went flying, you're mainly flying through nitrogen. So that's all right. It's only if you go swimming.
Okay, good.
But is that another example of something that we think of as a gas, and it's so cold there that it changes the state of things? And actually, on Titan, these things, it's a liquid, and there's lots and lots of other materials, chemicals like benzene, acetylene, which you might know from acetylene torches and things like this, butane, which you have in when you go camping. So those will all be solid because it's cold enough. Methane's actually one of the few things that stays liquid at those temperatures. And so one of the things we're doing is we're taking, and actually one of the experiments I'm going to do soon is literally to take camping gas and to see what it solidifies, because we've been trying to work on getting proper mixtures and things like this. But the interesting thing about Titan is it's a natural environment, and so we thought, well, let's just try like some easy mixtures to start with and see what we can look at. And someone said, oh, what about a camping gas? And I was like, it's not a bad idea. So those are the sort of materials that will be there. That's
cool. So Sam wants to know, if we have liquid methane, does that mean it rains methane on Titan?
It does indeed. I'm very glad that this was brought up. We actually, not only do we think it rains, so Cassini actually studied the whole Saturn system, but kept a very close eye on Titan for 11 years, and it sadly ended in 2017. They actually threw it into Saturn just to make sure it wasn't gonna crash. It was very spectacular, but quite sad. But while they were looking at Titan for those 11 years, they saw clouds, they saw what they think are rain events. So they think that absolutely there is a hydrological cycle, but hydrological means water, so it's not. It's a methane cycle where it evaporates up, forms clouds, and then rains back down. But the thing to say is it will be very slow, because what happens when you get cold is everything slows down. So that's true. At this point, it's and a lot slower.
Fly. So we could fly above the methane clouds, presumably. So we'd be
probably. It'd be interesting to see how far we could get before it got too thin and we'd start,
Anyway.
How
cool is that? Oh my goodness. Oh, I love talking to you, Helen. Anyway, where else shall we go?
Where else should we go?
So Nicholas wants to know which planets can have life.
which planets can have life? Oh,
Yeah.
that is a good question. And actually, it's like we're not entirely sure. It's sort of like we know what planets can have life as we know it, i.e. not many. You know, in order for us to be happy wandering around, we need reasonable temperatures, we need some oxygen, we need some source of energy. We're quite, you know, us and elephants and things, we're quite big. There's a lot to go on there. But in terms of things that are like bacteria and things like that, they're not so fussy. So there's a lot of bacteria that we know of, and even small little creatures like if you look up these things called water bears or tardigrades. Yeah, they're very space hardened, and we know that they can survive some pretty extreme life. So things like that could survive places like Mars. So Mars we know is a bit like Earth. There is some water around, it's a bit rocky, it's just not got a very big atmosphere, there's not a lot of oxygen around and things like this. Then of course recently people got excited with an observation from Venus. Now Venus is a terrible place.
Oh, it's awful.
It's awful. It's hot, it rains acid, it's got high pressures, but they've seen evidence of a molecule that they think can only come from life. And so some people are thinking, ooh, maybe they could live in the atmosphere and float around like big balloon type things. So it's sort of, and then of course if that can be the case, then why can't they live in Jupiter and Saturn and places like that? So I think at the moment that we don't know enough about what we call extremophile biology. So that's the extremes of what can live in. And also we don't also necessarily know enough even like about Mars and places like that to know where they could actually be. So there's it's a growth area, planetary science. There's a lot more to be done.
So much, because the universe is massive.
Yeah, and this is aside from the moons, which of course places like Europa and even Titan has been suggested as a good place to be as a bug if you fancy it.
Definitely.
Yeah.
So
where can we go next?
I've got a couple of questions here actually that I think we've landed on Saturn here, which is looking a bit
it's
odd.
looking a bit
I think
gorgeous.
that
it's looking gorgeous.
It's looking great, but
just
like
upside down.
I think it's upside down. Yeah.
No. It's just we're looking at the rings from the other side.
Anyway. So Mark wants to know, do the rings reform over time? So remember how we were talking about how in about 10,000 years the rings on Saturn might be gone? Do they reform over time, do you reckon?
I can't see any reason why they couldn't do. I'm not totally sure, if I'm honest, and I can think of the number of people to ask that question to, and none of them are me. I could imagine that if they are a temporary thing, and like for instance, if Saturn's rings haven't been there for the beginning, that have formed later on and things like this, that definitely that could be the case. I'm not sure. There's been some theories that like the rings are like when something has got too close and then has been ripped apart and things, but there's actually not that much mass. I think you've got a fact about how thin they are. They are terribly thin.
I learned this the other day and it legitimately blew my mind because I thought they were quoting the wrong units, but the rings themselves are about as wide as the distance between the Earth and the Moon. But when you look at how thick they are, they're literally only 10 meters thick. And I mean meters, not kilometers, meters. Like
it's like two houses on top of each other. And that's it. And we can see them. Yeah, we can see them from here.
It's crazy.
Yeah, it's immense. So there isn't much material actually in there. And so it's like a big enough comet that happens to wander too close, gets ripped apart. Yeah, I mean, it's certainly a question for I could suggest a few people. I will ask them when I see them next.
Interesting. Okay. You'll have to report back and I can report back to these guys as well. So Hey Kim wants to know, how big is Saturn? I'm so sorry if I'm saying that wrong. How big is Saturn?
Gosh, really big.
Super big.
Super big. And it's this is terrible because you know,
I might actually have this written down somewhere.
This is the sort of thing, unfortunately, when you get a bit older, You're like, oh, numbers. I could just look that up on Wikipedia. And so you don't always remember. The one cool thing I do know about Saturn is if you could find a bath big enough and you put Saturn in it, Saturn would float.
Yeah.
Because the overall density of Saturn is less than one big gas
It's crazy.
planet. It is crazy. That's crazy.
Yeah.
So I just like the concept of having a really big bath and sat in it, you know, enjoying its bubble bath. Yeah. Well, obviously it's not as big as Jupiter. Hang on, I'll do a quick search.
No, so it says it's 9 times wider than Earth. That's what I've got.
That sounds about right.
So 9 times, yeah.
So you can just
it's big.
imagine 9 times Earth along that.
Yeah, 9 Earths. Well, I think you could fit a little bit more than 9 Earths, but if you lined them up across the center of Saturn, you would have 9 of them. So it's really big. Really big. Cool. Well, shall we go and see if we can investigate another moon? What do you think?
Absolutely. Oh, another moon.
Where do you want to go?
Ooh.
Another moon, or maybe we could, yeah, where would you like to go?
Oh, I was going to say, well, we could go to a moon that nobody knows much about.
Oh, yes, I'm keen to learn.
There's a few of them. So Uranus and Neptune, they're the 2 gas giants that everybody sort of forgets, and they're like, nobody loves us, because like we've sent a spacecraft, lots of spacecraft to Jupiter. Well, Galileo and Juno were the 2 big ones. We've sent big spacecraft to Saturn, that's Cassini, and we're sending another one, Dragonfly. We sent a spacecraft to Pluto all the way out in New Horizons, but we kind of missed Neptune and Uranus, and they're like sitting there going, hey guys, what about us?
I'm here,
hi. So Uranus has tons of moons. We don't know much about them, and they're all named after Shakespearean characters and Shakespearean and Alexander Pope characters, who's a poet. And Uranus also has rings. So one of their moons is Miranda. I think Miranda's quite a good moon.
Let's see if I can find it.
But I was thinking we should also then step to Triton after this. Have a quick look at Miranda. So there's a number of the moons. Is it not on the handy list? What about, is there?
That's all right, I can search. I found it, I'm pretty sure. We'll see if we.
It's got a really cute one called Puck as well.
Yes.
They're so cute. But they're all, we don't know much about them because we've never really got, we just went through Uranus.
Oh no. Oh, actually, while we're flying there, Jenny wants to know, why do some planets have more moons than others? Because I mean, we visited Jupiter and Saturn. And those ones have a whole lot of moons.
A whole heap of moons.
Yeah.
And obviously we only have one moon. Mars has 2.
Some planets don't have any.
Yep, Venus and Mercury don't have any. It's sort of to do, there's lots of potential reasons. We think that Mercury and Venus don't really have moons because they're too close to the sun, and that the sun would sort of like knock it off and things like this. Not really a stable place. We're not even that sure why we have one big moon. There's thoughts that a big Mars-like object collided with Earth very early in our history, and that's the leftovers and things like this. Mars's 2 moons are 2 rogue asteroids that got too close, and one day one of them is going to crash into I think it's Phobos, which is too close, and so it's slowly circling down and down and down, probably not for a long time, so Phobos is okay for now.
That's good. Okay.
With Jupiter, Saturn, Uranus and Neptune, it's all their sort of leftover stuff. So these moon, or at least this is one theory, that these planets came about where at that point in the solar system ice could condense, water ice and other things, straight out the solar nebula. It was that cold, and they ended up with these big balls of ice that got so big that they could actually start gravitationally grabbing more gas, so like hydrogen and helium. And so they literally just inflated like balloons. And so that's mainly what Uranus, Saturn and Jupiter are mainly made out of, hydrogen and helium, and then Uranus and Neptune are mainly made out of water and methane and ammonia because it's a bit colder out there. But then there was a lot of stuff left over from this process, and that's what they think made all of their moons. So this and for instance, so Miranda here is mainly water ice, we think, on the surface and things like this.
Yeah, I was just looking at the surface. It looks really weird.
In a bit we'll go to Neptune, because actually Neptune and its moons is a bit weird, actually. So maybe we should go to Triton, because unlike all the other gas giants, Neptune doesn't have many moons. I think it's got 2.
Really?
Yeah, it might have a couple that are like tiny little potatoes around it. Sorry, potato is a good, because they're like not spherical, or they're like an asteroid or something like that. But that's it. Miranda is cool because it's got these big stretchy bits in it. So one thing is we're kind of excited that it might have like rifts on it, and so it might be like Io, it's tidally moving up and down. And
awesome.
So it's going to be a long time before we get there to study it, but
because it takes a long way.
It's a long way, and there's not a planned mission for Uranus and Neptune at the moment. But yeah. So, should we go to Titan? Triton.
Okay.
Triton. So the reason that we think Neptune doesn't have many moons is because Triton is a bully.
Really? It kicked all the other ones out?
It kicked all the other ones out. So actually, in Triton, we think is very, very like Pluto. And this is one of the reasons why it might be very exciting to get there soonish, because obviously in the last 5 years we've gone from knowing nothing about Pluto to it being a little fuzzy blob to suddenly we know everything about it, and we'll talk a bit about it later. Triton's about the same size as Pluto, and we think it might have been, like Pluto, attempted to be a planet at one time. So I suppose people might know this, that Neptune and Pluto's orbits actually do cross, and that sometimes Neptune's actually the furthest planet from the sun, and Pluto, when it was a planet, was actually a little bit closer. I think actually when I was born, that was the case. The thought is that Triton could have been like that early on, but wandered too close to Neptune and became a moon. Neptune's like, I like the look of you, you could be my moon. But the problem is, because Triton is so big, it bullied all the other moons out the way. So there's only one other moon who's a lot further away, who was obviously out of the way of the destruction. And it's called Nereid. And it's pretty cute, but it's a little potato again. So there's sort of a lot to study. This is what we're seeing here in terms of the images we saw of Miranda and the images of Triton. They actually came from one spacecraft that was called Voyager 2. So I did lie a little bit when I said we've never been to Uranus and Neptune.
Been there once.
We've been there once, and that was for a flyby mission. Voyager 2 and Voyager 1. I don't think Voyager 1 went to the icy gas giants, just Voyager 2 sort of flew past, and it's still going out of the solar system now. So
it's a long way out now.
It's a long way out. So that we've sort of had a tantalizing glimpse. We know that they're very interesting places, but we haven't gone back yet, which is I think what a lot of people like me get very sad about. I have a lot of friends at NASA who are a bit like getting a bit impatient, because they're like, I really want we want to go, because they're also like my age, and they're aware that we've still got to build the thing, and then it's got to get there. And they're a bit like, will I be retired by the time it actually happens? So,
I want to go to there.
Yeah, exactly. So, and that's something you don't think of, but when NASA and ESA plan for these missions, they have to plan very carefully and make sure that, like, the important people who have lots of knowledge, but they're a bit older, and they have to plan for the fact that they may be retired, they may not be around by the time
it takes years to get there.
So they have to work with, so they have to make sure the teams are multi-generational, they call it, so are from all ages, as well as diverse and interdisciplinary and things like this. So it's actually when you plan a NASA mission, you have to say what you're going to do if your important people all retire. before it gets there.
Things that you did not think you had
Yeah,
to think
it's
about.
a funny thing, isn't it, that you have to plan for these big long things.
Yeah,
So
definitely.
but yeah, so
Okay.
Triton for
Cool.
me is one I'd like to know a lot more about. But yeah, we should see what people's questions are.
Yeah, definitely. Well, I was just going to say, we have time to go to, I reckon, one more place. And actually, Tatenda wants to know, does Uranus have a planet 9 behind it? I mean,
Planet 9 or Planet X is a source of a bit of controversy. So so we know that Neptune, it was actually it's Neptune which is the furthest out, and so for instance we knew Neptune was there, and it was actually my favorite scientist, Mary Somerville, was one of the person who did these calculations, and she was part of the calculations because they knew from the way that Uranus was wobbling a little bit that there was another planet further out.
Yeah, right.
So then they made a lot of adjustments, sort of targeted look. This is around the 18th century or so, and they found Neptune. So then they've since done the same thing on Neptune and found that it's being pulled around a little bit. And they thought, right, that's it. There's another planet out there. And then, of course, in 1930, Pluto was discovered. But now that's where we're going. But now a lot of people, because Pluto's not that big. I think that like Pluto was discovered and then went, is that it? Now there's some people who believe that or have calculations that support that something else bigger is pulling Neptune, and it's too big to be, so I should say Pluto, which is in front of us now. Oh, so beautiful.
I'm going to change the field of view. Give me one second.
Pluto is actually one of the reasons Pluto suddenly didn't become let's say when I was growing up, Pluto was a planet, and now
too.
It's kind of sad, but now it's one of the biggest dwarf planets. And the thing is, we know of a number of dwarf planets that are further out than Pluto. That's one of the problems with Pluto. We know places like Eris, Hanume, Makemake, and places like this are all planet-sized objects, and we call them Kuiper belt objects and things.
Right.
But yes, and so Pluto, so there's still people looking for, they think that there might be something bigger, almost potentially Neptune sized out there, but we've not spotted there. But I think that really just shows you, like, you know, astronomers look at galaxies and things like this, but even within our solar system, it is so big that we could be missing a giant planet. And not really know about
which is mind-blowing, right?
It would be mind-blowing.
There could be something out there. There could be
something out there, and we don't know for absolutely sure. But yes, so all these beautiful images we have of Pluto came from that plucky little piano-sized spacecraft called New Horizon, which whizzed past in 2015. And I think what made a lot of people very excited is that we kind of expected it to be like bit dead, a bit rocky, I don't know, not much going on, but we saw there's loads going on, and actually this is beautiful. It's coming across.
I was hoping it would be in the sunlight.
One of the best things that we see, and the thing I really like, is this big heart-shaped glacier. It's now called Sputnik Planitia, and what we think that out there in Pluto, it is so cold that this is frozen methane and nitrogen. So these are the gases in our atmosphere and the cow farts, where it's so cold and they're liquid on, and you know, it's cold enough for it to become liquid on Titan. It comes out here, it's so cold, these are solids. And the really funny, the cool thing about these solids is they're quite wobbly. So, and that's to do, and so I've just actually last year did a big study on both nitrogen and methane at these really low temperatures at around minus 220 degrees C and things.
Oh, that's cold.
It's pretty cold. Yeah, you don't, and it's like, uber frozen bees. And it's really funny because even though they're really that cold, you'd think that they'd be quite solid and they'd be quite locked in together, but they're not. They're actually quite like jelly.
Weird.
I call them wobble ice.
So
but that's kind of cool because they're sort of still wobbly and like jelly. That's the reason that we can have that beautiful glacier that sort of wobbles over the surface. And that's the reason it can move around. So
if you could like somehow get a really big massive hand and like shake Pluto, that whole heart shape would just be like
potentially, yeah. And if you look really close, that's a really good way to wobble it off. If you look at some brilliant pictures from it, so the New Horizons website, you can see there's like polygons in it, and they think that's where things are slightly warmer happening, and it's sort of like wobbling up, and these little sort of upwellings are happening and things like this, and blobs across the surface. So so they think the glacier is quite young and probably moving around.
So Jenny wants to know how long, and this kind of relates to my question as well, how long does it take to get to Uranus, Neptune, and all the way out here to Pluto?
It depends.
You know roughly how long it took?
Yeah, so it depends what you want to do. If you just want to fly by, which, for instance, New Horizons did, I believe it took about 7 years. And by the time it got to Pluto, it was actually the fastest human-made object. So basically, you just start accelerating, you keep accelerating, keep accelerating, keep accelerating, and just keep accelerating. Because there's nothing to slow you down. You just keep going. So you can actually get there quite quickly. I think with Uranus, Neptune, you're putting a foot on the gas, probably get there in, I don't know, 4 or 5. Uranus probably 3 years or so, and Uranus depends. There's lots. If you've ever seen the movie The Martian, there's like a whole person, the Rich Parnell character, whose whole job is orbital dynamics. There are lots of things you can do by slingshotting around planets and things like this. The problem with Uranus and Neptune is what we really, really want to do there is to do what Cassini did in Saturn. And Cassini actually took 7 years to get Saturn, because you can't just have it accelerating, because otherwise it will miss. You need it to be slow enough that you can then get it into orbit around Saturn.
So it's kind of like the planet has to catch it.
Yeah, the planet has to catch it. Yeah, exactly. And if you're going too fast, then the planet's just like, no, go fast. So I think I've seen, or at least seen some calculations that they reckon they can get to do, and they're getting better at these, they can make them more complex, do the slingshots and things. They're getting better at these calculations all the time. That I think they've got it down to about 8 or 9 years to get to Neptune, which is to get to Uranus, which is pretty swift, considering Cassini took about 7 years or so to get to Saturn, to be at the right temperature. I could be a bit wrong in that exact numbers, but that's the sort of time scale that we're looking at to get to that point. And there's literally people in NASA whose job is to work these things out, which is quite a cool job, actually.
That's very cool. Unfortunately, I think we're running out of time, which is so sad.
I've talked too much.
No, you haven't at all. I do have another question. As we fly back home, though. So Evie, she wants to know. Bye, Pluto. Evie wants to know, where is the question? It was all the way up here. Oh. She wants to know what the moon is made out of. So we've talked a lot about moons. Yeah, what's Earth's moon made of?
Well, it's not cheese, I'm afraid.
Oh no.
One of my favourite cartoons was Wallace and Gromit when I was growing up. So the moon is made out of sort of frothy rock, and it's rock that is very like our crust rock on Earth. So if you were to go out, Evie, and pick up a rock, there's a very good chance that the moon's actually made out of pretty much the exact same thing. And one of the reasons that that's quite interesting, and it actually could be very important for us on Earth, is that it comes to that idea of where we think the moon came from. So we think very early in Earth's history, there's sort of Earth is trying to do its thing. It's all hot and it's not a particularly nice place to be. And some of this rock is making a very thick lid. Then you get a Mars-sized object sort of collides with the Earth, and some of the material and a lot of that lid of rock gets stripped off and then becomes the moon. It sort of wiggles around. There's some beautiful animations. If you look for animations of the moon forming, it's quite pretty. So he probably did us a favor. So it stripped off some of that lid of rock because the Earth ended up with quite a thin crust. And that's actually been, well, quite important for us, because we end up with what we call plate tectonics, that it's thin enough that we don't just have one plate, like for instance Venus does. Venus does not have plates, it's one big plate, and that could be one of the reasons Venus is a terrible place. But because we have these plates, we get a lot of our sort of chemistry and our nice molecules come from the bottom of the Earth, and they have a place to get out. So in a way, the moon probably did us a favor by making our crust a little bit thinner. That's one idea. And of course, it's very, very beautiful.
It's lovely.
It is lovely to look at.
It's beautiful. It's one of my favorites. Anyway, I think we've run out of time, which is so sad, because there's a lot of really, really cool questions here. If people want to ask you questions, is there somewhere that they can reach you?
I'm more than happy for them to email me at my ANSTO email address, which is helenmc@ansto.gov.au, or you can catch me on Twitter. I'm there quite a bit, and I'm at Helen_E_MC.
It's a cool place. I like your Twitter page.
Thanks. I try to make it nice, friendly.
It's really fun.
I talk a lot about neutron scattering, so I apologise in advance.
It's fun. Thank you so much for coming and having a chat to us about all of the moons in the solar system, and just, oh my goodness, I love it so much. I learn so much every time I have a chat with you. It's great.
They're just fun places, and I think sometimes they don't get talked about. I think Mars gets a lot of attention, which it deserves, but I think a lot of the other planets need more attention too.
Definitely. But yeah, thank you so much for joining us. It's been so wonderful having you here.
It's always fun.
Good. Like I said, we'll have to get you back here in person at some point. And guys, if you would like to come and visit Science Space as well, hopefully we're going to be reopening very soon. So come on, and very soon, who knows? It's all very hand wavy. Keep an eye on our Facebook page and we will let you know. Fingers crossed. But in the meantime, we have lots of really cool things happening this holidays. If you just head to our website, and on the very front page, you should be able to find a link to go and have a look at that. If you want to find out some more solar system things, me and my friend Amanda are going to be doing a live show on Facebook tomorrow, which is going to be fun. And next week, we are going to be talking with another wonderful woman in STEM. The wonderful Professor Lisa Harvey-Smith is going to be coming to join us. Yeah.
She'll know a lot more about the stuff beyond the solar system. So that's where my knowledge stops, but she's a genius.
She's going to be teaching me and all of you guys so much about really cool things that are beyond our solar system. So come and join us for that, and all the links that you need are on our website as well. So it's going to be super fun. Thank you so much for joining us, everybody, and thank you so much again, Helen. Can we get a massive round of applause just where you all are?
Thank you. It's always lots of fun.
Awesome. Thank you so much, everybody. We will see you in the next one. Bye.